The velocity of a particle in meters per second can be modeled by a periodic function v of t for t is greater than 0. Now, okay, so a particle, basically you have this object moving, and this is going to be the velocity. Here is your graph showing that. So you have this weird periodic function, which means it repeats every now and then. A portion of the graph is shown below. Including units, what is the average rate of change of the velocity from t equals 1 to t equals 21? 9 plus 10. So let me see here. These go by normal numbers. So when t is 1, I have what appears to be, oh, this doesn't go by numbers, normal numbers. That's 1. So t of 1 is 1. Terrific. Let's find 21. It's not there. So when you have a periodic function, here's a little trick. I don't want to continue this graph because I'm not a good artist and I don't want to try to draw the grid. That's no good. It looks like what happens is this repeats every 1, 2, 3, 4, 5, 6 spaces, right? We start out by going one flat line, then down, then up, then down, then 2 flat lines. So every 6 spaces, it repeats. In order for you to find out what's going to happen at 21, what you do is you take 6 and you divide that from 21 and find out your remainder. So 6 divided by 21 is 3. 3 times 6 is 18. Your remainder is going to be 3. So t of 21 has the same behavior as t of 3. And at 3, 1, 2, 3, you get 2. Okay, so now we need to set this up. We are being asked to find the average rate of change. The average rate of change is given to us by the formula f of b minus f of a over b minus a. Well, in this case, I don't have f's, I have t's, and I do have f's. I have v's, I believe. There you are. So it's going to be v of 21 minus v of 1 over 21 minus 1. V of 21 we already said is 2. V of 1 we already said is 1 over 21 minus 1 is 20. So to put it all together, because they want us to include the units, we have 2 minus 1, let me get my calculator, is 1. We have over 20. And this is the average rate of change, which is something per second, meters per second. So meters per second. Now, some of you might be thinking, you treated t of 21 like t of 3. That's correct. But it still is 21. So we're not going to do 3 minus 1 down here. Very, very, very tricky. We still have to pretend that we're extending all of this time over here. But, you know, that's what we get. 1/20th meters per second. Not very fast this particle is going at that amount of time. But it's average rate of change, not total distance traveled or total, rate. So kind of a bizarre problem.